Hello. In this video, I wanted to present the work I've done in the past 3 or 4 days of learning at Red Hat, where I wanted to learn how to control a robot with the voice with the help of AI. So the robot I'm using, it's this one. It's a MakeBlock mbot robot. It's a simple one that I bought for my son, but I'm actually the one using it the most. I could have done it with mine, which is the homemade equivalent, but it would have required some Arduino programming, and that was not the point of this day of learning. So yeah, I want to control this robot with the voice. This robot, it can already be controlled with Bluetooth from a Python library, which reads and writes into Bluetooth to make the robot move and beep. So let's see how this works. Let me share my screen. And sorry for the infinite loop. I have only one. So here. So to control the robot, I will need different elements. And I forgot to mention that I'm using 2 systems. One is my main laptop, and the other one is a MacBook Pro, which has a powerful GPU. So that's where the AI model will run. And another point that was important for my work is that I wanted to have everything running locally. So nothing on the cloud. All the AI and the glue is running in the AI is running in the MacBook, and the glue is running in my computer. So first thing we need, it's whisper.cpp. Whisper.cpp, that's an AI project that translates voice into text. Can be said in English or in French. It will be translated in English. So I launch it remotely with SSH. I connect to the Mac for the different remote commands. So now it's getting loaded in the GPU memory. Next step is the AI model. The AI, it received text, and with the help of the MCP protocol, it can call functions either running on the same computer, if it's local, or across the web, the internet, if it's HTTP. So here, I launch just the model itself. So again, on the Mac with Ramalama to have it running against the GPU. It's being loaded in the GPU memory. It's the GPT OSS model that I chose for this demo. So now it's running. And the last part of the servers, it's the MCP server. So I need to turn on the robot because the MCP will connect with Bluetooth to the robot. You should be able to hear the beeps of the initialization. So I launched the MCP server, and it's connected with Bluetooth. I can show what the MCP is offering, the MCP server. So that's the function that are exposed and visible to the AI model. So it can move forward on a given number of steps. So we see here that the actual command to the Python library controlling the robot, it says move steps, that's the number of seconds for which the wheel should turn. And they will the left and right wheels will turn at speed 200. Now, if I want to turn right, I move for 1 second with one wheel moving backwards, the other one moving forward, the opposite for turning left. And turning around is similar, but just for 2 seconds. And last thing the library offers is just to make the robot beep to say that it's alive. If I quickly go to the mbot library, we can see what's happening when there is one step missing, robot lib. So robot lib, we see that for moving the robot, it gives the order of for the wheels to turn, sleep for a given number of seconds, and then stop every wheel movement. For the beep, it will go through, it will activate one tone for 1.1 second. And what I wanted to show here was what's actually done at the lowest level of this stack to actually control the robot. So here we can see that when we request to move, we write some bytes here, some sequence of bytes into the Bluetooth serial connection with the robot. And the robot firmware will detect the byte sequence. It knows that this one must activate the wheels. Then it receives the speed of the left wheel, the speed of the right wheel. Similar for the buzzer. Again, a predefined sequence of bytes, the tone to play, and the duration of the beep. So I think that's it for the part actually controlling the robot, the part which is usual Python programming. So I can close that. So here we have our 3 servers, the one controlling the robot, the one turning voice into text, and the one turning text into Python requests. So we can go to the glue. And the glue, it starts with the Ramalama chat application. This one, when I launch it, it connects to the model and it gives me a prompt where I can discuss with the model and control the MCP server and the robot. So if I tell make the robot beep, so here you should hear it. We see the query that was made to the model. The model answered to execute this query. We need to call the tool called beep, and that was executed, and the robot beep. I forgot to mention that here, to ease the troubleshooting and development, I've got a file that I can look at, and as soon as an instruction is sent to the robot, it will be printed in this file, so that just from the screen I can control what's going on. I don't need to have the robot even on. I can just mimic it, and if this file is correctly written, it means the robot should be correctly controlled. So now we know that we can control the robot. We need to control it with the voice. So that's the last piece of the stack, the audio transcription. This one, it will record from the microphone, send it to the whisper.cpp API, get the response back. Then for each of the instructions, it will send it to this server, which gives it to the model and to the MCP server. So to give it a try, I won't keep the robot in the desktop. That would be dangerous. So let me change the camera and move the robot. Should be good enough like that. All right. Put this here. Is it visible? No, it's not. Here, yeah, it's visible. So let's try to talk to this robot. So I execute this audio transcription script, which is the overall glue. And I press enter to start recording. I will say turn left, move forward of 3 steps, turn right, and beep. So we see here that the instructions were translated. Then turn left was executed. Move forward of 3 steps was executed. Now it should turn right again. Oh, it's out of the screen. Doesn't matter. And finally, we see that it beeped. So that's overall working well and as expected. I don't even know where the robot ended up. Yeah, so I take that back. That's it for this demo. Yeah, well, that's the different piece required to control a robot. That's not the most efficient, but it's working, and I can explain how each of the steps work. That was my goal for the day of learning. Thank you. Bye-bye.